Good morning, or good afternoon, depending on when you're seeing this video. Today we're going to learn about Unit 2. We're going to go through parallel lines. We're going to talk about a few basic things, and then I'm going to go over quite a few details and examples pretty extensively, and then I'm going to give you an assignment to go along with it, and there'll be more definitions on there that you could read just in case you didn't quite catch it in this video. So we're going to go over these little postulates here. Corresponding angles postulate. If two parallel lines are cut by a transversal, okay, so let's try to get some context here. These two guys here, these two lines here, A and B, they're parallel, okay, they're parallel. And this is how you represent that mathematically. Line A and line B, A and B, two straight lines like that means that they're parallel. Okay, and it says it's cut by a transversal. Cut by a transversal. A transversal is just a line. It's just a line that cuts between the two parallel lines. This line right here is the transversal. Okay. Then pairs of corresponding angles are blank. Okay, corresponding angles meaning that there's one on the inside and there's one on the outside, and they're on the same side there. This meaning the outside, this down here is also the outside. Inside would be between the two parallel lines, okay? So here would be inside or interior. On the outside here would be exterior, okay? When you have both of them combined like that, like this angle's on the outside, this angle's on the inside, those are what you call corresponding. So if I'm looking at those, what do you think they are? If you're looking at angle 1 and angle 2. I would say that they are congruent. Congruent. So over here, statements, A and B are parallel, so that means that angle 1 is congruent to angle 2. Reasons, I'm not really going to go over that today, so I wouldn't worry about it. Next one. Alternate interior angles. Alternate meaning it's going back and forth from one side to the other, alternating. So this one is on this side, it's on the inside, and it's on this side, so it's on the left, and it's on the inside, this angle 3. So it's interior angle, and then you have the angle 4 right here. It's still on the inside between the two parallel lines, so it's on the inside, it's interior. And they're alternating sides, okay? One's on the left side, one's on the right side. That's why they're called alternating interior angles. And if you look at that, this guy is pretty small, this guy is pretty small. So when that happens, and you have alternating interior angles, they are also congruent. And if you go to the statements, line A and B are parallel, and 3 and 4 are congruent. Again, I'm not going to worry about the reasons. If you really want to know about the reasons, all you would have to say is reason 1, line A and B are parallel. Reason 2, alternating interior angles are congruent. But there's not enough space to write that. Alternating exterior angles. So this time I have alternating on the left side here, left side of this line, and on the right side of this line. So they're alternating one side or the other, okay? And they're on the outside. They're on the outside out here, so they're exterior, okay? Then these pairs of alternating exterior angles are also congruent. Okay, so if A and B are parallel, then 5 and 6 are congruent. All right, next one, consecutive interior angles theorem. If two parallel lines are cut by a transversal, then pairs of consecutive interior angles are what? Well, if we're looking right here, we're looking at line 7, and we're looking at, or not line, angle 7, and we're looking at angle 8. If they're on the same side and they're both on the inside, same side, and they're both on the inside, okay, these angles are what we call supplementary. Supplementary. And over here, you can say angle 1 is, or 1, A and B are parallel, 7 and 8 are supplementary. They add up to 180 degrees. All right, so let's try some of this in action. You'll be able to see it a little bit easier down here. It'll make a little bit more sense, okay? So if I have angle 2, so I'm looking at angle 2 here, and it's 113 degrees. What is angle 6? Well, angle 2 and angle 6, this one's a big angle, this one's a big angle, so they're the same, so that means that angle 6 is 113. Easy. Next. Angle 4 is 100 degrees. Angle 4 right here. Angle 4. It's also a big angle. Angle 4. What is angle 6? Well, it's also a big angle. If this big angle is 100, then this one's also 100. Okay, next one. We have, if the measure of angle 1 here is 84, what is the measure of angle 3? So this is a small angle. This is also a small angle. Both small angles, so angle 3 would also be 84. Okay, what about angle 7? It's 75 degrees, and then angle 1. Well, if you look at this number 7, it's a small angle. Number 1, also a small angle. So they are the same. So 75 degrees. All right, angle 3, it says it's 81 degrees. 81. All right, what is angle 4? So now we're looking at a big one. So we got a small one and a big one. Okay, if you have a small one and a big one, you're going to have to set it equal to 180. Because if you combine both of those, angle 3 and angle 4, if you combine them, it makes this straight line here. Okay, if you combine those two, it makes that straight line, which is 180 degrees. So what you got to do is you got to take 180 degrees and subtract the angle from it, which you already know that angle 3 is 81, so this is 81. So think of it like a big old slice of pizza. This is a slice of pizza, that's a slice of pizza. And together, that slice of pizza is 180 degrees. You ate 81 degrees of it. So you're going to, if you ate 81 of it out of the 180, how much of your pizza is left? So you're going to take 180 and you're going to subtract 81. Should get 99. All right, what if the angle of measure 6 is 111? Okay, so that's a big angle. Big angle is 111. What is the measure of angle 3? Okay, so I have a small one and a big one. If you have a small and a big one put together, it has to add up to 180. Small one, big one. Small one, big one. Small one, big one. So these two together equal 180. I know one of them is 111. So I need to take 180 and I need to subtract 111 from it. And you get 69. All right, let's keep going. If Q and P, or P and Q, are parallel, and the measure of angle 1 here is 75 degrees, find the measures of all the angles formed by the parallel lines cut by a transversal. Now I know this doesn't make very much sense because that angle is clearly bigger than 90 degrees. Okay, it's an obtuse angle, but these are not drawn to scale. Okay, it's telling you what it is. 75. So that means that if that's a big angle, and apparently it's 75, so all the ones that I'm about to highlight in blue are the exact same thing as number 1. Because those are all big angles. All the other ones are small angles. So if angle 1 is 75, then angle 3 is 75, angle 5 is 75, and angle 7 is 75. Okay, well, if I know that a straight line adds up to 180, and these two right here put together would give me that straight line, then I would take 180 and subtract 75 from it so I can figure out number 8. Should get 105. Now all the ones that I'm about to highlight in red are big angles. Well, they're technically small according to the picture, but they would all be 105. So 105, 105, 105, 105. And we're all done. Hopefully you can see somewhat of a pattern over here whenever I highlighted them in blue and red. Okay, hopefully you can see some type of pattern. I'll let you come up with it. Let's keep on moving along. So now we got to figure out, are they congruent or are they supplementary? Congruent, add up. I'm sorry, congruent just means the same. I'm thinking of something else. All right, and supplementary means adds up 180 degrees. Okay, so that's whenever you have a big one and a small one, a big angle and a small angle put together, supplementary. Congruent means they're both big or they're both small. Okay, so let's find out. Number 1, DHG. DHG. So if I look at that, that's a small one. Small. See how that's small? Smaller than 90. Okay, and then we have HGA. 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 That's also a small angle. So small and small. So if I said small and small, that means that they are the same. Or I guess in this case we got to say congruent. Okay, number 2. If I have FHC, so this is another small one, FHC, and then I look at DHG again, small angle, small angle, small angle, small angle, both small, same word, so they're congruent. All right, let's look at the next one. We got BGE. So I got to start at B, then I go to G, then I go to E. So BGE. So these are small ones, small. It's a small guy again. And then FHC, FHC. So that's another small guy. So I got a small guy again, and that's another small guy. So small and small would make this congruent because they're the same. All right, number 3 down here. Well, that's weird. It says 1, 2, 2, 3, 4, 5. That's weird. Anyways, EGA. EGA, so that's a big angle. You see how that's bigger than this guy up here? It's bigger than this guy right here. This guy is way bigger. Okay, so we got EGA and GHC. GHC. So this guy is big, and then this guy also makes a big one, a big angle. Big angle, big angle. So they are congruent. All right, AGH. So I'm at A, then I go to G, then I go to H. AGH, AGH. So this is a small angle here. This is small. Okay, this guy's small, AGH. Now if I look at EGA, EGA is a big one. Remember we just talked about that. That's a big one. And then AGH is a small one. So I got a small one and a big one. Small and big, they're opposite ones. They're going to add up to 180. So this one you'd call supplementary, because they are adding up to 180. All right, last one here says DHG. DHG, that's a small angle. DHG, small. And then BGH. BGH, oh, that's a big one. BGH, that's big, big one. And DHG is a small one. So I have a small one and a big one. That means it's supplementary. All right, now let's get down here to the algebra. I'm going to do these 2 problems here, and then we'll call it a day. So it says solve for x and explain your reasoning. Okay, well, if you notice that this one here is a big angle here, it's a big one, and another big one. These are corresponding angles. Remember, if you go back to the very beginning of this video, I talked about if one is on the outside and one is on the inside and they're on the same side, they are called corresponding angles. Corresponding angles. So if they're corresponding, they're both big angles. Okay, let's make it common English. Big angle, so they're the same. So that means I could set them equal to each other. So I got 17x minus 4 equals 12 minus 15x. Okay, I got x's on both sides of my equal sign, so I need to move my x's to one side or the other. For me, I'm going to move my x's to the left side, so that means I got to get rid of the ones that are on the right side. So I got to add 15x, add 15x. That guy's gone. This guy comes down, this guy comes down, and then 17 plus 15 gives me 20, 30, 32. 32x minus 4 equals 12. All right, now I need to add 4 to both sides. Add 4, add 4. It's gone. This guy comes down. 32x equals 16. And then my last step is to divide by 32. So you get x is equal to 16 over 32. If you type that in a calculator, it should give you 0.5. 0.5 is technically kind of like, if you think of money, it's 50 cents, which is also equal to half a dollar. Okay, so a half, or I guess you could say 0.5, whichever one floats your boat. All right, let's try number 2 over here, and then we'll call it good. So these two angles are both interior angles. This is a small one. This is a big angle, small angle. Remember when we talked about that right above this problem? For example 5 up here, all of these problems here, if there's a small angle and a big angle, they equal supplementary. Supplementary meaning 180 degrees. So what you have to do is you have to set both of these guys, you got to add them up, get both of these guys, put them together, and equal it to 180, and solve for x. So I have x plus 67 plus x plus 127 equals 180. Combine your x's and combine your numbers. So you get 2x plus 67 plus 127 is equal to 194, equal to 180. It's really weird. It's going to give you a negative number, but that's what the problem says. All right, so subtract 194, subtract 194. 2x comes down, and you do 180 minus 194, and you get negative 14. Last step, divide by 2, and you get x is equal to negative 7. So x is negative 7 in this case. Now you can plug that back in and actually figure out what the degrees would be of those two angles, but that's not what the problem asks for. So I'm going to stop there. This video is probably a little lengthy by now. If you have any questions,